for variables. We are at this control chart for variables, and we started like a construction of X bar chart. X bar chart is standard deviation mu, and no, the relation we have seen that central line calculation of central line and upper control limit and lower control limit we have studied. Okay, so now we studied like we are discussed like capital N and small n. Capital N denotes like total population. Small n is denote like sample, and based on that we discussed upper control limit, lower control limit, and upper warning limit, central line, like that. So we solved few problems related to this, and we are into that R bar chart also we have drawn, where sample size n is equals to 10, D2, D3, and upper control level. And so we have designed this kind of chart. Again, we are at no, we discussed X bar chart. It is a X bar chart. X bar chart is equals to summation of xi divided by k, where I is equals to 1 to up to k. So here, I is the number, maximum number, where X bar is the arithmetic mean of ith sample. Ith means the maximum number of sample, like it's a 10th sample or 11th sample, like that. R bar is also, we discussed, summation of Ri divided by k. So I is also, you know that. Okay, so okay, here again here upper circuit limit and lower circuit limit, X bar plus 3 or divided by D2 square root of n, and lower circuit limit is X bar minus 3 or divided by D2 square root of n. So we have given some formulas, and R chart also we have drawn. So where we stopped in last class, R chart, preparation of R chart. R chart is nothing but population standard deviation. Okay, is not known, is not unknown. So here, not unknown, known. So here is nothing but unknown. So here central line is equals to R bar is equals to central line is equals to R bar is equals to summation of R divided by K, and upper circuit limit is equals to R bar plus 3D R bar divided by D2, and that is also like RD4. Like we have seen this where D3, D4, where you can see the D3, D4 can be obtained from the table statistical constant control charts. Okay, constant charts. Right. So we stopped here, and let's say using this following charts, 12 samples are there. Sample 1, 2, 3, 4, 5, 6, 7 up to 12. Here I is equals to I value is equals to 12. I value is equals to 12. You can see I value is equals to 12. Like I is equals to 12, where I is equals to 12. Okay. Now let's move on to okay. Now you can see here, right side I mentioned I is equals to 12. So here sample number 1, 2, 3, 4, 12, and they given this. So for this, we need to insert extra column, that is we call as subgroup. Subgroup. So here this element we form first row we formed one group, second group, third group, fourth group, fifth group. Same. And we are going to calculate the total. So here I am going to share total. You can total it. You get 1.04, 1.98 as it is. We'll get 5.02. And here here 4.98 will get this value. We will get these values. So totals we are going to do this. This is the first step we have to follow. So what we did, subgroup, and we are totaling the sample. Sample 1 total, sample 2 total, sample 3 total, and up to sample 12 total. Individually, you have to carry, in examination, you have to carry, statistical calculator or else calculator, have to total it. because for fast calculation. Now we are going to calculate X bar. Now X bar, X bar. What is the formula for X bar? X bar. Okay, you can see here X bar, X bar, where it is X bar. Summation of X divided by K. You know that K is equals to 12. So summation of X is nothing but values. You can total all those things, will get divided by 12. You'll get this X bar. Okay, X bar. Now you can total it 12.04 divided by 12. We are going to get 12. Okay, 12 point like 1.03. Okay, so now you can see here, you can total like this entire thing, you'll get 12.93. So let me share Excel. Let me share one Excel sheet. Hope my Excel sheet is visible. Hope my Excel sheet is visible. Please yes
Yes,
or
sir.
no.
Yes, sir.
Okay, fine, good. Now, what we are going to do here is, this is a sample. Okay. Now, we are going to, the problem they're given. I am going to insert one more column, like subgroup 1, 2, 3. So we are totaling sum. I used the formula called sum. So no, we can do like this. Sum of 1, sum of 2, sum of 3, sum of 4, like that. So like that, we are going to get the values. Okay, now we are going to get the values like this. So here, subgroup of 1 total 12.03. Now I'm going to again back here. Hope you are going to see that our material, right? So here, now you are getting 12.04 divided by 3. That is equals to 0.003. That is minute one. Similarly, 12K, second value 0.06, like that we are going to get. And R bar, okay, R bar. So R bar is equals to summation of R1, okay, divided by K. Here R1, summation of R1 0.75 divided by 0.025, and summation of S. So here we are going to get like 0.3. So these three value R and S, RS, we are going to take from this formula by using RS. Okay, and so now we have no, central line is 1.03 here. Okay, and upper circuit line is equals to 1.03 into 3 into 0.60 into 0.25 divided by 2 point this 0 point, like this we are get, since n is equals to 5. Sample here is 5, and D2 is equals to 2.234. So here see, this is the 0.2234. So then we will get this upper circuit as also we are going to get this. And so here the control limits can also determine using the factors A2 and C2. So here n is equals to 5, A2 is equals to 0.59, and X. So this is how we are going to calculate. Let me share one more screen. The calculation part I did in Word. Okay, so that you can easily understand. Hope my Word screen is visible, right?
Yes, sir.
Okay. Now here same control chart, average X bar, R bar need to average. No, same step, calculation of average range. So 1.04 divided by 5 is there, right? 1.04, 1.004. We'll see the range is like 1.04. Okay. And I'll share my entire screen. So that you don't have any kind of confusion here. Yeah. Now my screen is split into two parts. You people are able to see my screen in two parts.
Yes, sir.
Right. Now here sample average where that is nothing but x bar 1.03, that is minute c we are going to so here range is equals to 1.03 minus 0.98, that is equals to sample 998. We need to 98. Where is 98? Where is 98?
So lowest one, sir. Second.
Second one. You can see here 98. Okay. So here 98 sample 0.606. So second average, you can see 0.9. You can see here again. Second sample. This is the first sample. This is the second sample. Okay. 0.998 plus no. I think pointer I need to use the. This is the second sample. So here the average of second will get some range. Right, range is equals to 0. No, we'll get 0.13 03 minus 0.98. We'll club together. Sample is 0.05. That is sample is 3. Like that sample 3. So sample 3. Similarly, up to sample 5, we are going to calculate range. Like I'll clear all. We'll get the values like this 0.04, okay, 0.98, okay, 996. You can see here the 996. Okay, now you can see here 0.104, like next 0. You can see 0.98. Like this, we are going to get the values and calculation of overall standard deviation x bar. So those values we can divide it by standard deviation divided by 12. That is square root of standard deviation is square root of 0.04. So square root of these values you can see here square root of this value, and we'll calculate this first calculation of average and standard deviation R charts. And calculation of control limits, upper control limit, that is equals to overall plus 3 into standard deviation. So that's 3 into 6, like that we're going to get. And finally, calculation of x and x bar, calculation of x and R bar, we are going to calculate here. And R charts also we are calculated. That's no, you can see here that slot is 0. Like that we are going to get. So I don't have any kind of board something. If you draw, this is taking like 1 hour to calculate. Try to understand. Okay, upper circuit limit. Okay, lower circuit limit. No, central limit. So here we are going to get same kind of things here. So this is population is no. Population to be no. Okay, now same kind of thing while we are going to chart the values we are going to give in chart. So here almost one here. I'm going to maximize this. Okay, so values we can assign. So first value, second value, third value, fourth value, fifth value, like that. So upper control limit, lower control limit, we are going to fixed, and the values based on the values that can be varied. So this is called R chart. So next, you can see here, sample range is 0 to like 0.14, upper control and lower control. We are going to draw like this. Next problem here is the following data given for 10 sample size for 10 sample of size 8 each production of certain component. So they given reading of 10 for 10 sample of 8 each production. So 8 each. Now here they're given sample 1, sample up to sample 10. Mean they given. Range is also they given. So mean given, range is also given. Now we need to draw X bar chart and R chart, point which samples, if any, are out of limits. First, we need to calculate control limits for X bar chart. Control limit for X bar chart. So X bar is equals to summation of X bar divided by K. Now here, if you total it, summation of X bar, like 5.444, okay, you can total it, we'll get like, let me do some kind of calculation here. 5.04 plus 5.1 plus 5.4 plus 4.9 plus 5.2 plus 4.7 plus 5.1 plus 5 plus, okay, there are two more components, are 5, again 5 plus 5.2. So that is 51. You can see 51 divided by 10, 5.1. So X bar is equals to 5. Then we are going to calculate X bar upper control limit. X bar plus 3R. 3R divided by D2. Now you can see here. N. Here N is equals to how many samples they given? They given 8 samples. N they given like 8 samples. D2. D2 is nothing but 2.87. 2.87. Okay. And further R bar is equals to square root of R divided by K. So square root of 6.5 divided by 10. That equals 0.65. So now we are going to consider it like this. Okay. So here we are considered 5.1 plus 3 into 0.65, because 0.65 is R bar calculation. Okay. And divided by 2.87 D2. 2.8847 into square root of 8. That is equals to values we are going to get. This is 5.6. This is upper. This is lower. So here plus, there is a minus. Now same value we are going to subtract lower circuit. So control limits range chart is equals to control limit is R bar is equals to 0.65 and upper control limit is 1 point, that is D4. D4 is nothing but D4 into R we need to calculate. So there is 6 point into 1 point. Lower control limit is equals to this. So, and we are going to give this into X bar chart. So we are going to 5.4 first value, 5.4, next 5.1, next 5.1, where is 5.1? 5.1 second value. Next third value is 5.4. Again, it's going to up like 5.4. Okay. Next value is like 4.9. So this is the 4.9 value. Okay. Next value is 5.2. 5.2, we are going to get 5.2. So this is called, we are going to draw upper circuit limit and lower upper control limit and center line and the lower control limit. So we are going to draw this. This is how we need to draw. And similarly, range chart, R chart. So here, range they given 0.4 and 0.8. How we are going to get 0.4 and 0.8 range they given 0.4. Same. So first problem here is we need to find out the upper control limit and the lower control limit. So this is the only problem here. While you are using calculator, scientific calculator, so here I think in computer it is there. So it's a standard calculator. We don't find here we have some kind of square root kind of thing, and there is a scientific calculator. So this is a standard calculator. Okay. So this, no, if you expand this, you'll get scientific calculator. This is scientific calculator where we have square root calculations. So you have to practice this. Okay. This is how we are going to give some kind of thing. Very simple. We need to understand the formula for control chart, like control limit, like X bar, and lower upper control limit, lower control limit. So values, we need to keep that values as upper chart and the lower chart, and we have to place this. Next, construction of mean and range and mu charts. So here, there is a step one, decide the characteristics of dimension to be considered to take measurement characteristics like length, width, or sample units selected at random, and sample need to selected random can be happen. And let us consider K independent random samples drawn each of the size En, and examiner process the control or not. So let us calculate the values of sample mean, that is equals to X bar is equals to summation of, you know that. So let X1 to Xk, okay, that mean value of observation is group first, second, and kth range formula. So R is equals to range largest value in the subgroup minus smallest value in subgroup. So R1 and R2, R2 and Rk. Subgroup first one to K. So this is a step 2. Step 3 is calculation of X bar. So 1 divided by K into summation of Xk, where K ranges from 1, 2, and K subgroups. So calculate the range of subgroups follows like this. Okay. Now X bar chart. Excuse me, 1 second. X bar chart. Now standard specification, when standard value mu, standard deviation okay, mu, and so here upper circuit is mu plus 3 sigma into square root of n. So center line mu and control limit this. So now case 2 standard deviation is specified. So what is standard is specified when standard values are mu. So here mu and are not specified. So specified and non-specified. We are going to calculate using these formulas. Okay. And standard deviation charts also we are going to see. And so here, this is how we are going to see. And we are going to following the data shown the formula values of mean X and range of 10 samples. No, here we are given 10 sample of each 5. So calculate the value of central line, control limits, and chart, mean chart and range chart determine whether the process is in control. So sample number 1 to 10, mean and range they given. So here we are going to calculate X bar, mean range. So we need to total it, divide by 10. So we are getting, so we need to total it and get 6.3. So after calculation of X bar and R values, need to calculate the control lines. So here X bar plus A2 R. So A2 means 0. 0.577 into 6.3. That's going to be, we are going to get. So that's called 14.3. So upper, like same thing, minus we are going to get. Okay. Now you can see this upper circuit limit and lower circuit limit, and we can draw the charts. Next, range chart control limit. Now upper circuit limit and D4. We are going to see like same thing, upper control control and lower control values they given. Like here they give 7, 4, 8, 5. We are going to given 7. Now here 7 R values, right? 7, 4, 8, 5, 7, 4, 8, 4, 7, 9. So whatever the R values they given, you have to represent into chart form. Only problem here is we need to define UCL and LCL and CL. That is the only problem. Okay. So this is how no. The next, estimation of standard deviation for X bar and R charts. So here the construction of control chart mean range following the databases of fuses. So fuses sample 5 being taken. So 5 being taken every hour. So sample 5. So here 40, 40, 42 like this they given. So sample mean determination. So sample number 1, 2, 3 and 12 they given. What they need to do here is, so 40 to 60 they need to summation, and summation divided by n mean they calculated, or maximum, no, or maximum of xi, minimum of xi. So here you need to find the maximum here, 87, 87 minus least 40, for 87 minus 40, 47. So r values we have to calculate. Okay. Now, same thing. Here, maximum number 90, least is 42. 90 minus 42 is 48. Here, 80 is 82 is the highest, and 10 is the least. 80 minus 10, 72, like that. So maximum minus minimum, that is R bar, that is mean value, and R value we are going to calculate here. Okay. So control limits charts. So x bar divided by k. So x bar divided by k. Now you are going to get 860. It is summation of 860 divided by k. K is equals to number of sample number 12. Okay. Now we are going to get this, and the summation of R bar. So summation of R bar 732 divided by 12, that is equals to 61. Now we are going to get upper subgroup x bar plus A2 plus R bar 71.2 plus 0.577 into 61. You are going to get the values. Okay. So this is how we are going to get this values. And no, sample number 8 to 10 falls behind that control limit. This indicate that process does not under control. Indicate the presence some assignment cause variation that must be detected, corrected, and elimination these points. X bar chart we get reserve limit. Now we are going to get upper circuit limit and lower circuit limit. Now here sample number 8 and 10. Sample number 8 and 10. 8, what happened? So here 160. No. So this is going to be observation. You will get it's going behind that. No, behind the limit. Okay. So process is not under control. Under control, as indicating that present some of the assignment caused variation because dedicated calculated. Now you can see here 8 and 10, 84 and 42, 84 and 42. So this is not under control. So it's going behind that. So 10 is above upper circuit, and lower circuit. Now we are going to correlate this by this picture. You can see here 8 and 10. So this is 8, this is 10. It's going behind that values. It's going behind the values. You can see here. Then we need to correlate. So this is how no quality. So it's like no this matrix, this values, this matrix. No, it may fallen in between upper circuit, in between upper UCL or LCL. It's fine. If go behind the upper circuit, go or above that upper UCL and below that no LCL, we need to cross verify the sample and that unit. So that they'll go, they're going to correlate this, correct with this sample. Take that batch and retest this. This is how it's going to be happen. Next, control chart for attributes. That is P chart and NP chart. P chart and NP chart. What is with what we mean by P chart? A product is defective when it is not available. When it is not available, fulfill the functionality which is produced, or two control charts are defective, namely P and NP charts. P chart is fraction. P chart is fraction and defective. P chart is fraction and defective. So used to proportion of defectives in process. NP chart is number of defectives. So used to number of defectives. These charts can based on the binomial distribution. For example, if 1000 bulbs produced uh, then 999 bulbs could be good. That's glowing when connected electricity, and bulbs could defect that's not glowing. So no, C chart. C chart, it talks about it. It must have several defective called imperfection. So, but a product is not defective unless a defect prevention product from the functioning for its intended use. Further, if a defective refers to product component that could not cannot be used, while defect refers to a quality characteristic of product component. Example, if a typist type one page, he or she must be made one or more many type errors. Okay, if typist, even you can write, you can type in word, you will type. If there were 100 meters length with 1 mm thickness, and the length of the wire, possibility that thickness of some place is little or more than this. So this is called C chart. C chart about minute. Okay, so why so the control chart, C chart control chart used in these cases, C chart control chart. C chart is to the number of defects the problem based on Poisson distribution. So control of chart for fraction of defective, P chart. Control of chart, number of defectives, fraction of defectives, P chart, and number of defective, NP chart, and number of defectives as per unit, C chart. So P chart, NP chart, and C chart we are going to use. So construction of the C chart, P chart. So there are two steps. So compute the fraction of defectives each sample following the formula. So fraction defective P is equals to number of defects in sample divided by sample size N. Sample average fraction of from this sample should be calculated. So P bar is equals to number of defectives in all sample combined divide by total number of items or units. Calculate the control limits explained below. Standard specification. Upper UCL P, that is equal to P3 square root of P1 minus P naught, okay, divided by N P naught. So that is equal to P naught is equals to A into square root of P naught minus 1 minus P naught. So lower, same, plus or minus. So where P is equals to process, that is population, fraction of defective. So this, you can see here standard. Now many of the same values P is unknown. Okay, P fraction is used. So no, it's like it's not specified. Earlier it's specified. It's not specified. No summation of P bar plus 3. So P bar CL is equals to P bar minus the P bar plus 3 is equals to lower. So here it's not plus, it's here minus. Okay, it's minus. You can see here. It's minus. Upper circuit, it's plus. It's minus. I think it's printing mistake. So you can try to rectify it. It's minus. Again, I'm repeating here. Now, step 3, graph sheet. Consider the sample number of x-axis and p values and y-axis. And draw upper circuit limit and no, LCL and UCL and LCL. CL. Okay, next. Contribution of construction of NP chart. So here, compute the average number of defectives, number of defective constituted by formula. NP total number of defective divided by number of sample inspected. So here, standard specified P is equals to fraction of defective of process population. So number of defective as per number of defectives as per sample based on a sample of same number of process. And if P specified the P value, then NP chart. So here NP is equal plus 3 square root of NP, same thing. Here minus same thing. So here standard not specified. Same thing NP here P dash instead of P dash. So no, P bar we are going to get. Same thing. And construction of C. So here number of defect of all samples. So here we can replace this, same thing you are going to get. We'll see small problem, two problems. One in a blade manufacturing company. Sir, why sir we want to use this kind of thing? We'll see here. For example, let's go for example. In blade manufacturing company, if they produce 1,000 blades are examined daily, following information is shown. Defective blades obtained there too. Draw P, NP, and given your findings. So here, day 1 and day 15. How many days? 1 to 15 days. So number of each day defective blades, 9, 10, 10, 5, something. Randomly, no, they'll have the defective one. So given information no problem, n is equals to 1000. They give clearly manufacture 1000 blades examined. So each and every day they are examining 1000. Single day they are examining 1000. The sample is n is equals to small n, not capital N. N is equals to 1000. K is equals to 15. How? K days, 15 sample size. Okay, days. And let's P bar is fraction of defective. P bar. Okay, now here day 1 sample. Okay, number of sample inspected, number of defectives. Now n minus here P is equals to DI. So this divided by 1000. So it's P. P bar means we need to total, we need to sum and divide it by, okay, you can divide by KP. No, P bar, total number of defective, total number of observation. Like 166 divided by 15,000, that's equals to 0.011. Now NP bar. So N is equals to, you know that N 1000 into like 11 average. NP bar. Okay, we calculated NP bar. And we calculated NP bar as well, control limit. So here P bar, like P bar is equals to 0.01 and 3 into square root of P bar 0.01 minus 1 minus 0.011 divided by 1000. No, we are calculating P bar. Similarly, this. So P chart is presented figure. Okay, here we know this is the P chart. You can see here upper UCL and LCL. The values lies here. So where these values are coming 0.09, 0.01 like this. So here, no, these values they are going to P values. That's called P chart. It's very simple. It's very simple. Now NP chart. NP chart. NP chart, you know P bar, NP bar minus N into P, this values, NP chart. So, N value that is equals to, N value is, N value is, N value is, N value is 1000.
1000.
Okay, okay, good. Now, NP bar. So here, we are going to take this N into P bar. So like this 11, the NP bar is equals to 11. Already we discussed NP is equals to 11. 11 plus 3 square root of 1, we are going to get same kind of thing. 1 minus P bar. Okay, P bar we are going to get, and NP into this kind of thing. And we are going to get some kind of values, that is upper UPL is equals to NP bar 20.84. 20.84. Okay, so you use here and 1 point like this. So now we are going to see here this value and this value. NP chart. Let's see NP chart 20.89. This value 9, 10. So where 9, 10, 11, 10, 12, 8. So this is called NP value. No, number of defects 9, 10, 12, 8, 7. So this column, this column, this column. Okay. Now we are going to draw NP chart. It's very simple, right? Now here, based on that, so above figures, the clear that no sample were falling outside control limits. Hence, it is concluded that process is in control. Now we are into quality control. Sir, why sir we are doing this exercises? So quality. Now, if anything is go behind that upper circuit or below that lower circuit, then we need to retest that particular day sample. Okay, here it's not going anything. So here, then here next one more problem. The number of defects is on 20 items is given below. How many items? 20 items given below. Devise the suitable control chart and provide your comments. So number of items 1 to up to 20. And number of defects out of 20, number of defects. Then what they'll ask, and provide your suitable control chart, C chart. They'll ask control chart means C chart, and provide comments on the process. So C chart, C value. Now you want to 2 plus 0 plus all together 20 values. We can total it. 35 will come. The average number of defect divided by total number of sample. 35 divided by 20, 1.75. Now that is equal to, okay. So C bar, you know that's 1.75. Okay. Now upper C into C plus C, the 3 square root of C bar. 1.75 plus 3 into, we are getting 5.772. And C, you know that. And lower LCL, lower control limit. Now C bar minus this. 1.9 minus this, that is equals to minus 2 point. That's, we in short we have only CL control limit, not upper. Lower control limit is minus, we don't have, we'll take it as 0, we'll count it as 0. Now from the above figure, now even you can see here, is there any event is occurred in between across the like upper control limit 5.72 in the figure? 1,
So
2,
6 and 8.
and 8. 6 and 8. Which sample it's crossed? Sixth sample and 11th sample.
Yes, sir.
Sixth
6th and 11th.
sample and 11th sample. It crossed. They'll ask the comment process based chart. So what they'll do? So withdrawn. So here from the figure, evidence sample 6 and 11. Already we discussed 6 and 11 outside of the control limit. Hence, revise the control limit should be calculated. One need to remove sample value of 6 and 11 should be removed new control limit and needs to be calculated. So what they'll do, we need to do C values. So revised one. Now 35 minus 8 minus 6. So 8 minus, we need to remove this. 8 minus 6, we are removed this. So total 35 minus 8 minus 6, 20. Okay. So minus 2. 20 minus, we removed 2 values. Here also we removed 2 values. That is equals to 21 minus 18. We are going to revise that control limits. Okay. C bar, once we remove 2 values, 1.17, and upper control limit is 4. Say process is same and same minus. Now again we are going to observe sample values given problem, compare with 2 values, revised control limit, and comparison can be observed that all accepted, deleted from within the control. So it's all about this chapter. Do you have any questions? And problems are there. If you don't have, you don't understand the problems. Now I'm going to share my email ID and to you, and you can drop mail and you do WhatsApp to me, and I'll drop my WhatsApp number as well. Okay. If you want any questions related to these problems, you can send WhatsApp or no.
Sir, excuse me, sir.
Yes.
Sir, do we get these kind of questions in the exam?
Of course. Of course. It's simple, right? You'll get one problem. Now, even you can see suggested readings. They'll mention each and end of the unit, each and end of the model examination questions they given. Long, short-term theory is there. You can write it, and problems. You can see 6th question onwards is problems.
Yes, yes, sir.
You have to do some kind of exercise. So anyhow, you have internal choice, right?
Yes, yes.
Internal choice, right? You have internal choice. It's going on internal choice. No problem. Okay. Right.
Okay.
Okay. Right. Have any questions? Still no?
Sir, like how much percentage of question these kind of questions can be expected on the question
No,
paper,
that
sir?
we can't assure, but my duty is to explain the content. We can't
Okay,
even
sir.
predict also. It's external examiner. So most of the times, if you practice this, it's very simple, right? C chart, NP chart. First thing is you need to understand the concept. The problems and all you have to practice, then only it will come. Otherwise, if you read like this, no, it can't digest for you. So there is a like 60-40. Even examination setter also, they know that you are belongs to distance education, not regular education. They keep in mind that so they'll give some kind of diplomatic questions which are very easy to solve if they are given.
Oh,
Okay,
okay.
clear? Now we'll quickly move on to eighth unit. Eighth unit. So Japanese FIS concepts. So why Japanese people? Already we discussed unit 2 or unit 3. No, Japanese quality control. Japanese are more and more towards quality is concerned. So they'll have very good quality practices. Now here, evaluation of management practices, present principles of management, and no understanding of 5S and 5S success. How to initiate 5S implementation, implementation of 5S, and initiation implemented benefit. So it's all about 5S. So 5S practices. So we'll call as 5S, 5S. So 5S means what? So stands for 5 Japanese word. When translated in the Roman script, start the letter of S. Initially, the principle of within 5 years were being utilized decade before Henry Ford. So it has reported prior 1920. Ford was during can-do manufacturing process. So acronym of can-do is stands cleaning up these things. Today, it is increasingly 5 years is management 5 years no 5 years is management technique in enhance productivity, competitiveness in order to become world class Gemba. So organization through this continuous systematic report. So 5S concept of 5S. 5S management tool is Japanese focused established quality environment organization ensure that in order to standard in the process, foster spirit and continuous improvement. 5S five management techniques. 5 management techniques are founded in any organization. Competitive okay. 5S philosophy is organized managing the workplace workflow intended to efficiently uh, eliminating the improving that reducing the process of unnecessary 5S reactions. So composition of 5S technique. 5S technique is it is a well-organized workplace, complete visual controls and environment that has a place, everything is its place. A place for everything in its place when it needed. So here, produce a workplace that uncluttered and safe organization. People combine together. So we'll see 5 years. What is the 5 years? 5 years. So no, 5 years often to element a larger lean initiative. So we'll start with words like 5. We'll have words like first we have a word called sort. We need to sort. Sersi. That is separating of essential from non-essential. Filtering. Set. Set in order. So organization of essential material where everything has its place. Shine, clean the work area. Standardize, establishment a system to maintain 5S habit. Sustain. Sustain is nothing but establishing a safe and sustained work environment. So here, sort, set in order, shine, standardized, and sustain. So these are the 5S principles they follow by Japanese people. Even now, all world is followed 5S principle. Again, I'm repeating: sort, set in order, shine, standardize, and sustain. So these are 5S. So 5S is just a cleanup campaign. No, we'll have raw material or any clumsy of files are there. Let's have an example related to this. If you go to one office, if you ask for one document, what they'll do, sir, document is there here or not, I don't know, sir, I need, they'll pick that word, the document, and they'll pick another one, and again this they revised. If it is happened, it's time waste process. First, they need to sort. If you go to medical store, for example, branded medical store, any medical store, if you give any kind of strip, I can give any strip, medical strip, what they'll do? They'll paracetamol, Dolo 650, like Ecosprin. So they'll sorted with alphabetical order, alpha A B C D like that. Have you observed that? Alphabetical order, sort. That is called sort. That is separation of essential from non-essential items. And if you ask eye drops separate. If you ask like syrups are separate, sort, filtered. Okay, first sort, separation of essential, sort. Then set in order, alphabetical order. Shine, cleaning in the work area. So then work area should be clean and standardized, maintaining approximate, sustain. So that can be sustained. So these are the component related to 5S. So 5S is not it's no prevention to determination, the ability to what's important, attention to details. So here, Cersei, that is the tightness sort. So here section orientation, set in order, set the proper place, a quick reveal of storage, shine, clean the workplace, and standardize the way of maintaining, sustain. So it's a habit, take habit and here 5S in improvement. Already we discussed sort, remove from workflow items are needed current production. So operation sorting that leaving only necessary when doubt there. If there sort is set in order, arranging need when readily, shine, sweep that clean and area, and standardize, sustain. So keys to 5S success. So in order to find system to success, most important factor is commitment to participate, involving everyone and sought visible support from the top management. So here, 5S model companies continuous improvement, train everyone adequately 5S practices, promote 5S campaign, plan systematic approach, and following plan, do, check, and act PDA. Plan, do, check, act PDCA cycle. Practice performance reward system. So how to hold 5S implementation? So here PDCA, plan, do, check, act. Plan, do, check. No, plan. Plan what mean plan? Provide the training to educate everyone. So it's not a single one task.
Sir, you are not audible.
Okay, we'll see next class. Okay, thank you. No, here power is not there. We'll see in next class. Almost 12:30. Tomorrow class, we are going to continue this thing.
Okay, sir.
Thank
Thank you.
you.
Thank you.